Okay, welcome to our talk on the future HTTP client. My name is Michael McMahon, and this is Danny Coward. We'll be both sharing this talk. So just to let you know that with some of the detail on these slides, there's quite a lot of text on some of them. So you might need to move a little closer to the projector or to the screen to be able to see some of them. So without further ado, I'll hand over to Danny to get started.
Great. Okay, so it was funny. Michael and I both came to this project independently. Michael did a BOF on this topic last year that some of you may have been at. And then I'm working now from the Java EE side. We were looking at a new HTTP client library. And then after Java 1 last year, we realized we were both sort of working on the same kind of thing. And this is how this is what happened. So here's the safe harbor statement. We're talking about some future plans. So the Oracle lawyers make us put this slide in. It says don't sue us if we get the date wrong. What we'll talk about is just a bit of the background, why we're doing this. We'll take a look at the new features in this library for JDK 8, but the bulk of the talk will be taking you through the new API, looking at API methods, and also some sample code to illustrate how it works. And then I think we've got some open issues because this is a work in progress, so we'll cover those, and then hopefully there'll be time at the end for questions. So I know everyone here has used HTTP, probably 80% of people in the world have used HTTP, but just to frame things, I thought it was worth reminding ourselves of the basic form of an HTTP interaction, as defined by the IETF RFC. HTTP request with request properties. Here's just a simple post to poem JSP. We have a number of headers. The specification defines headers that define metadata about what the request is about, what requirements it needs the server to meet. And then there's a payload on this request message, which can be in multiple different formats, text, images, video, etc. And then that gets sent to the connection gets established. The first thing that happens is the request properties and headers get sent to the server. Then maybe right after, maybe a little bit later, the request body, if present, is sent to the server. And the server has a little think. It will send back the status of the response that it makes, whether it's okay. And then, of course, we all know there are any number of statuses that mean lots of different things. But in general, after that, the headers are transmitted. And then finally, either right after the headers or on demand from the client, a number of different modes depending on the implementation, the body is sent back. So here the server wasn't very happy, so wants the queen to chop your head off. So this is the basic format. We all know that there are mechanisms within HTTP like redirects and security authentication interactions that live within the protocol. But just to frame this, I wanted to show that this is a request and response interaction model. And so now that sets things up for looking at what we've got today in the JDK. We've got HttpURLConnection. So let's take a look at using HttpURLConnection for this basic kind of HTTP request response interaction. So in this example, and this is where, feel free to move closer to the screens because we've got lots of small fonts like this to try and illustrate code that might be more readable closer to. We create a connection object based on a URL from the URL of where the connection is going to be made to. Then we're going to set some headers. Here we're just setting the content type of the request body to be HTML. On the connection class, we actually, because we're going to put a little request payload, a request body in, we happen to have to set a flag on this connection object to say, I'm going to put a payload on the request. Then we connect, then we open an output stream, we write the request body, and then we close that output stream. Then we look for a response coming back from the server. So this is a blocking call here, get response code, until the server has responded. Then we can read the response with a traditional I/O stream. And we can look at headers and so on in the response object. Now, this is, we've all written code like this. I'm showing you this because this is the basic template for any use of HttpURLConnection. If you use it, your method's going to look something like this. It's just going to have, different headers being set or different content payloads being set and read and so on. But they all basically look like this. So let's take a look at how this works for everyone. The problems using this API are fairly well documented. It's actually fun to Google the kind of complaints people have about this API. The first thing to notice is that the API of this connection object is spread across two classes in a hierarchy, and to make things worse, both classes, URLConnection and HttpURLConnection, have lots of methods. So if you're looking around in the Java doc for how to set a header, there's a lot of work you have to do. You have to do a cast here because the URL open connection method returns the super type. You have to cast down because we're using HTTP. When you set a header on the connection, you're calling a method called addRequestProperty on the superclass. But then when you read a response header, the method is called getHeaderField. So because of this, the way things are arranged, HttpURLConnection trying to fit into this more general framework, you have some inconsistent method naming. So none of these problems are the end of the world in themselves, but let me keep going. The next problem that people usually find is that because this is the connection object is modeling in a linear sense something that is a non-linear interaction. We're making a request, we're sending it to the server, we're expecting a response back, and yet all those different states, the request being being formulated, the request being committed, waiting for the response partially arriving, the response having fully arrived, all those different states that are inherent to the protocol are modeled on a flat, linear, single object with multiple methods. So it's very easy to call the methods at the wrong time. You can call methods let's take a look at the example I've got here. As soon as we call connect near the top, right under the try clause, that commits the request headers and sends those to the servers. So if you, as in this example, I've switched around the method calls. If I try to set a header, set more of the properties on the connection to do with the request, it's too late because I've already connected and committed the headers to the server. So in this example, as soon as I connect and then I try to modify the request that I am making, these methods throw illegal state exceptions to tell you you've done the wrong thing at the wrong time. And then equally, by calling getResponseCode, for example, on the connection, once the request has been committed, that will actually block until the response headers are read. By which time, if you're still in the middle of writing to the request body, it's too late. And you may not know this, but in this example here, where we call connection.getResponseCode, the first highlighted red line, and then we continue to write to the output stream to the request body, this actually fails silently because the request output stream has been closed by the implementation. So not only do we get inadequate state modeling, you get different kinds of reactions from the API when you do the wrong thing at the wrong time. And then, of course, Michael reminded me that the history of this API was to support the hot Java browser, which is one particular class of HTTP interactions, which really meant that they only needed at the time a blocking API for filling out the payload of a request object and reading the response object as well. So the only mode possible in this API is blocking I/O. And for many, well, even for browsers today that are, downloading text and images concurrently in a website, this kind of blocking mode is not really adequate, and there are lots of other modes that people would like to have. So this is all to say that while this API works for the common cases, or worked for the common cases probably 10 years ago, it's not really flexible enough. And because it doesn't model well this request-response interaction that's inherent in the protocol, it leads to a very difficult-to-use API in the sense it's easy to do the wrong thing at the wrong time. So I know, I've often tripped up using this API, and it's taken me a while to get everything in the right place. Makes it not very productive. So I think I covered all of these points in my example, except to say that the other drawback is that the only protocol provider, the only implementation of the HTTP protocol that this API allows is the one that's in the JDK. So if you have some super optimized implementation of HTTP, it's not possible to slot it underneath this API and let developers use that through the standard JDK API. So these were all issues that we thought needed addressing. And so over the years of many other projects, there are lots of popular libraries that do really a better job than HttpURLConnection of modeling HTTP request-response interactions. And here's just a short list of some of the more popular ones. When we started this project, we looked at these projects very closely and looked at all the different perspectives they took on how they would solve this problem, and tried to bring the best of the ideas from all of them there. So that's a bit of the background. So just to now talk about the new project we started. This is a work in progress, although we've been at it now for, almost a year. We have a stable API. The package is java.net.httpClient. We have a working implementation of the API together with a number of tests. So we've been building the implementation as well as designing the API. It's on the list for JDK 8. So we're working towards deadlines for JDK 8 on this project. And for those of you who want to download code and look at it, look at the API, see it working, see some of the test code and so on, there's the link there. We have a public java.net project for this. So the features are primarily to equal or exceed the functionality of the existing HttpURLConnection class, to better model request-response interactions, for it to be easy to learn and easy to use. These are the sort of classic drawbacks of the HttpURLConnection class. To provide more modes of operation, different ways of sending messages asynchronously, receiving messages, receiving payloads in different formats, and so on. There are now lots of technologies that build on top of HTTP. Many of the web service technologies build on HTTP. We wanted to make it easy for them to be able to layer in their own content models on top of our API. So this led to us wanting a formal filtering model as part of the API. We wanted to let other people plug their own implementations of this API underneath the API, perhaps suited to a particular environment, or perhaps optimized in some way, optimized for a specific architecture. And then there seems to be growing interest in the HTTP upgrade architecture for protocol switching initiated by an HTTP handshake, and WebSockets is a really good example of that. So we wanted to allow or have the API support that kind of mechanism. So now let's turn to the main idea in the new API. So you start with an application. The first thing you do is get hold of a client builder from which you're going to build an instance of an HTTP client. Then the HTTP client's job is to build request objects for you. And to do that, it uses a request builder. The request builder builds instances of HTTP requests where you configure the headers and the payload and so on in a variety of different ways. Then once you've formulated your HTTP request using the request builder, you pass the request back into the client in one of the execute methods, and this opens the TCP connection to the server, sends the request object, its headers and properties and payload in various different modes, and then at some later time when the server is ready, you receive a response back from these execution calls on the client. So every use of this API looks something like this. You create a client, you create a request object, you send the request object through the client, and you get a response back. It all looks like that. So you can see already we're trying to model the HTTP protocol more closely with an object model here, and we've added builders in for reasons we'll explain a bit later. So let's go back to the old HTTP URL connection example here, this very linear style connection-based API. So the new code looks like this. So you can see at the top the new package. The first thing we do is create the client instance from the client builder. Then from the client instance, which is highlighted in blue, we create the HttpRequestBuilder. And then on the request builder, we set up the headers and perhaps the body. If we were doing the body, this is where we would set up the body. So in this case, we're just setting a content type on the request builder and setting a simple string into the request body. And then when we build on the request builder, we get the immutable request object that we're going to use. In this case, we invoke the client object. We call the getResponse method on the client object, passing in that request we just made. And this example shows a blocking send. We wait until the request, the response object returns, and at that point then we can start examining the state of the response. And in this example, we just use traditional blocking I/O to read the response payload back. So this a little bit like the example I showed, the old example. This being the template for every use of HTTP URL connection, this example is essentially the template for every use of the new API. Every use of the API looks something like this. It's a variation on this kind of example. So let's just look at some of the high-level knobs and things we can twiddle when we use this kind of template. We on the client builder, this is where we configure client scope properties, and I'm going to talk about them in a bit more detail, but things like the connection pool, default timeouts for making requests, and so on. Then on the request builder, we will twiddle with the request scope properties like adding headers, configuring whether redirects work, perhaps overriding some of the default client scope properties. Then we have a variety of ways also on the request builder to fill out the request body. We have push and pull versions, streaming, setting with just a simple byte array, and so on. Then on the client object, where we see client.getResponse, we have a number of different ways to send the response, either in a blocking manner or asynchronously. And then once we've got the response object, we have a variety of ways, not just blocking I/O, to read the response payload when it comes back. So these are the ways that we can vary things. So let's just take a quick look at the main objects again. The HttpClientBuilder, that's the starting point for the API. This is where you build client instances. The client instance is used to send HTTP requests and execute and get responses back. The request builder builds and configures request objects. And then the request object that you create from that encapsulates the HTTP request. The response equally captures all HTTP response state, and we have a HTTP headers object that clearly is used in both, is consistently used both in the request and the response object to give a consistent view of header manipulation. And the reason we're using this builder pattern is so that we can make sure that the main objects in play during HTTP request and response interactions are immutable. The builder has all the mutability, and that's done at configuration time, but once those objects are created, they're then immutable. This brings a lot of benefits to developers. They can be accessed concurrently by multiple threads. It makes them very easy to debug. Once you have an immutable object, you know once the state has been set up, it's never going to change throughout the lifetime of your program. So if you're debugging with immutable objects, it makes it easy. You can rule out a lot of possibilities for what might have gone wrong. Then some of the secondary objects that assist these main objects in the API, the handler objects. So these are callback objects that come into play if you're using any of the asynchronous mode of the API. If you want to be notified when the response headers arrive from the server, rather than waiting on a blocking call, then you would use a response headers handler. If you want to be notified as the request body is being downloaded in pieces, rather than waiting for the whole thing to come down or waiting on a blocking I/O stream, you would configure a response body handler. If you want to be notified of errors during the execution of a request-response interaction, rather than sitting on a blocking call, you can get a callback using a response error handler, so you can be notified if there's a problem rather than sitting and waiting to find one. And then we also have our filter API for decorating, for modifying request and response objects, request objects on the way out and response objects on the way back in. And we'll talk in more detail about all these. We also have a simple API for configuring connection cache. We provide a default connection cache in the implementation, but we know that people perhaps would like to optimize that part of their implementation, so you can add your own connection cache if you want to. And we have a little API for upgrade handling. Bit slow. Okay. All right. So let's go back and look at the API in a little bit more detail. Again, this is the main template: the client, the request, the response, and the builders that make them. Creating a client builder, there's really two ways. There's just creating an instance of the builder, but then also useful once you've created a client instance and you may have set up timeout properties or maximum buffer sizes and so on, it's useful to be able to create a request builder using the properties of that client. So this is a quick and easy way to create a client builder with an existing set of properties that you've already set up for another client. Then a quick tour of the helper objects of each HTTP client instance. You can set proxies here. This is where you would set or reset if you wanted to override the SSL context. This is where you would override the, wow, that's a loud call. This is where you would override the HTTP connection cache if you had your own implementation of it. This is where you can use the existing cookie manager interface that's already in the JDK to provide your own custom cookie management. So this is good for if you've implemented one already. This is where you set and configure filters, and this is where you would perhaps override the default executor service if you wanted more fine-grained control over the threading properties. Then the more, rather than helper objects, the more property level flags here. We have you can turn on and off pipeline mode. You can set it to follow redirects or not. Setting the request and response body buffer limits that the implementation uses, timeouts, and so on. And also, usefully here, this is where you can select the implementation provider if you want to. So if you have somebody else's whiz-bang Linux super optimized HTTP client implementation, this is where you would ask for it. Then finally, once you've set all that up, you call build. That creates the client instance. And the client instance can then be used for multiple request response interactions, all that will share this infrastructure that you've just set up. And then all those helper objects and properties are available as accessors, as getters on the client instance. So just a quick example here. We just get the default client builder. We're going to set a proxy. We're going to allocate a fixed size thread pool here. We're going to use the default connection cache, but we want to have an instance of it that uses certain parameters for how many threads it will cache and so on. And so on. And you can see in this example, as we set these helper objects and properties, we're using the Fluent style. We thought this was a good fit for very declarative looking code when really you're doing a lot of configuration calls. Then the request sending methods are on the HTTP client instance, and there are two of them. One is send headers, and the other is send request. Send request is the main sort of workhorse. This is the asynchronous operation. You are returned a future object by which you can track progress of the interaction. And on the HTTP request, you may have configured those completion handlers for errors and body parts coming and request headers, response headers coming. So you would get callbacks then. Otherwise, if you want to do that traditional I/O, where you send the request headers and then do a blocking, write on an output stream of the request body, we have the second, highlighted in blue there, send headers methods that returns an output stream to the request body. Now the request builder, this sets up all the properties of the request objects, from the headers, the request body, any callbacks for the asynchronous mode operation, and any implementation specific things like timeouts and buffer sizes that you want to override from those client scope properties. And you create the request builder from the client instance, passing a URI. That's the starting point. And here you can set the method, set the request URI, set the headers in a variety of different ways. We try to add some convenience methods there. Again, this is Fluent throughout. The request builder also has other properties like setting the timeout, the request body buffer limit, and here's where you can set upgrade handlers for doing WebSocket upgrades, for example. A variety of methods that I think Michael will talk about in some of the code examples better, setting the body by byte, byte array, byte buffer, iterators of byte buffers. So you've got lots of push and pull methods for setting the request body. I talked about the response callback interfaces. If you want to be notified when headers arrive back, you use the response headers handler. Similarly, as the body arrives in pieces, the response body handler at the bottom, and then in the middle, the response error handler to be notified when errors come. And these are all added, these callback handlers are all added on the request builder. As you can see in this example, we create the URI, and then from the client we create the request builder passing in the URI, And then we set, in this example, we're going to set the properties so we have a GET request with a string as the post data. We're going to configure an error handler so that it gets called back if there's an error on the connection, add some headers, set a 30-second timeout on the connection, and then build, and then we have a request object. This is where we hand over. I'll just finish, we're just working out where we're going to hand over. And then the request API allows you to access all these properties on this immutable object that we just set up. So with that, we've now set up the request, and then Michael's going to take us through to all the other aspects.
Okay, so basically the next dozen or so slides I'm going to talk a little bit about the different modes of operation with some code samples. So basically there's three different things we're interested in here. The different ways that you can send a request and receive a response, the different ways you supply a request body to a request, and then the different ways that you can receive response bodies. So basically there's three, as Danny already introduced, there's three different ways, basic mechanisms for sending and receiving. You have the traditional blocking mechanism, and then the two new asynchronous mechanisms using either callbacks or future objects. So we'll look at some examples in a moment. And then the different ways that you can supply a request body. You can do it the traditional blocking output stream mechanism, and we refer to that as a kind of push mechanism. What we mean is that the application is kind of driving the data, pushing it down to the stack and out onto the network. Then second, there's a so-called all at once mode, and all that means is that the application will provide the entire request body in a byte array or an array of byte buffers. And then thirdly, we have our so-called pull mode, which uses either iterator byte buffer or iterable byte buffer. And I'll explain the distinction between those two types later on. But basically the idea is that the application will supply one of these iterator type objects to the client, and then when the client is ready to send the request body, it calls back into the iterator to retrieve the byte buffers one at a time. So for receiving response bodies, it's exactly the same. Basically, the same three options for same three different ways of receiving response bodies, either in all at once in a byte array or an array of byte buffers, or through blocking input streams or iterators, or then thirdly asynchronously using callbacks. So take a look at a very simple example. In this case, we just simply allocate a byte array. We call some method to populate the array, and we create a request builder and set the body. Call the setBody method, which gives the byte array to the request builder, and we build it. And then we just call client.sendRequest then to send that request. So to look at the pull mode now. So this shows an implementation of an iterator. Now the next slide will show a slightly more realistic example, but this slide shows you the methods on the iterator interface itself. Now we only use the next and hasNext methods. Remove, which is part of the iterator interface, we don't use it. So perhaps in JDK8 a default implementation of the remove method will be provided, and that would mean then users don't have to implement it. So again, what happens here is you call setBody with your iterator object, and you call sendRequest, and then as previously the implementation will call back to the iterator to retrieve the byte buffers one at a time using the next and hasNext methods. So to look at some better example perhaps of how this might be used, this example shows a new type called readable byte channel iterator. So this is a type that we will probably provide as part of the API. It's a relatively simple class that's 25 or 30 lines of code. So, but what it does is it takes a readable byte channel and returns an iterator for that channel. And in this example here, you can see we've created a file channel, which is reading from some file on the file system. So we create our iterator from that, and we call setBody with the iterator, and then send the request out. So here we've an example showing the use of the iterable type. So what's the difference between iterator and iterable? Well, iterable objects can return multiple iterators. So the difference is that in this context, if your application provides an iterator, you're saying, here's a bunch of data and you can read it once from start to finish. But on the other hand, if you provide an iterable, what you're saying is you can read it from start to finish, but if you need to read that data again, you can call into the iterable to get a new iterator, and then you'll be able to read the data again from start to finish. Now that's useful in a HTTP context in certain situations, such as say redirection or authentication, when a request needs to be repeated. And what it means is you can avoid having to buffer the request body data if the application has provided one of these iterable types, because we know that we can go back to the iterable to get a new iterator, which will regenerate the data from the beginning. Okay, I'm just going through this quickly. So just moving on then to some very simple examples. So this is a real simple, probably the simplest possible example of sending a request, in this case with no request body. So you can see we create a request builder, build a request from it, and then you can call client.sendRequest. But the highlighted line at the bottom then is where the blocking happens. So the client, we call it client.getResponse. So the calling thread just simply blocks at that point until the request has been sent out and the response has been received. So what if, to move on from that example, say you want to also do a blocking mode, but you want to send a request body but using an output stream. Now, as Danny mentioned earlier, there's a slightly different mechanism for that. You have to use a specific send headers call. And you can see there send headers takes two parameters, the HTTP request that you want to send out, and second, a numeric value which indicates the number of bytes that are going to be sent through the output stream. So that can be either a positive number, which is an exact number of bytes, or it can be the value -1, which indicates an indeterminate number of bytes, and the caller can send any number. So once you get the output stream, then you can use the normal pattern then for writing through output streams, where when you're finished you call close, and as in the previous example, then you just call client.getResponse to get the response to that request. So now we'll take a little look at the asynchronous interfaces. So a little code sample here. Now, if you remember a couple of slides back, Danny introduced the 3 handler interfaces. Now, these were defined as 3 separate interfaces, each with a single abstract method. So that means these interfaces can be used as functional interfaces for Lambda expressions. So I just want to show a little illustration of how Lambda might be used in that context. So we start off with a request builder, and then we call the onHeaders method with a little Lambda expression. And the left-hand side of the Lambda expression contains the method signature for the headers handler. And the right-hand side of the expression is the block of code that will be executed whenever the headers are received. So then we can do this exactly the same thing then for the error handler. So the left-hand side of the expression is the method signatures for the error handler interface, and then the right-hand side is the block of code that gets executed when an error occurs. And finally, the same thing for body part. So basically, the block of code there will be executed, and it will have access to those parameters that you see there. So we build that request and use the client to send it. Now, if you're not, if like myself, you're not 100% au fait with Lambda and exactly all the details, and I just wanted to put a slide in here to explain the kind of equivalence between that Lambda example and how you might have had to implement that before. So this would have been implemented previously prior to JDK 8 as an anonymous inner class implementing the HttpResponse headers handler interface. So by using a Lambda expression, you at the very least, you lose the boilerplate code there, but you also save the compiler having to generate this extra class. So that's a small advantage. But you don't have to use it with Lambda expressions. You can use a conventional handler class. So for instance here, we have a class that implements the 3 handler interfaces. Alternatively, if your application is only interested in 1 or 2 of those handlers, then your class only needs to implement whichever of them that it is interested in. Okay, so moving on quickly then to the other type of asynchronous interface, futures. So if you think back, in each example that we showed previously, the client.sendRequest method was treated as if its return value was void, but actually it actually returns a future object. So in situations where you don't set a handler, where you don't set callback handlers, then you probably do want to use the future object as the way of keeping track of the response. So in this example, we store the future object in a variable f, and then sometime later we're going to call f.get to get the actual response object itself. So we'll just take a quick look at the HttpResponse API itself. It contains accessor methods for all of the things that you would expect to see in a HTTP response, like the content length, content type, response code, SSL information if it's a HTTPS connection, and then HTTP headers objects then for both the headers and if there are trailers on the HTTP response. And it also contains a method which gives you a reference back to the request that initiated this response. And then, so now we move on to the mechanisms that are used for reading responses. So the first 2 methods we look at here are blocking reads that return the entire response all at once. So basically we have 2 methods, getBody as byte buffers. There's 2 variants of that, one where the application will supply the array of byte buffers, and the second one where they would be allocated internally. And so variants exist also for byte arrays. So 2 equivalent or analogous methods on HTTP response exist also for reading responses into byte arrays. And then if you want to read the response in a blocking or streaming mode, then we have 2 interfaces here, or 2 methods here. GetBody as byte buffer source, which will return an iterator byte buffer, or GetBody as input stream, which returns a regular Java I/O input stream. So I just wanted to show on this example how you can actually mix the different modes here. So say for example your application wants to use the basic asynchronous mechanism, but you also want to read the responses using an input stream, maybe because you have some legacy code which only understands input streams. So what you can do here is you can see in the onHeaders method, the implementation of that is checking for a response code of 200, meaning OK. And if everything is OK, then it calls response.getBody as input stream, and we get back an input stream out of that. And then the input stream is handed off to some kind of a reader thread then to read the actual response body. It could be read in line in the actual on header, or the method you see here, or alternatively through a separate thread. So that's. I wanted to move on then to some of the other types in the API. So the first one that I want to describe here is the filter API, which Danny described it earlier quite well. So basically, I'll just say briefly that that filters are blocks of code or classes that perform application-independent processing on requests and responses. So they're organized in a chain or a list per HTTP client. So an application can build up a list of filters and associate them with the HTTP client. And then that means that every request and response belonging to that client will be passed through the filters. So in the picture at the bottom there, you see the kind of sequence of events. So on the left-hand side, you see a HTTP request that would come from an application, and then it's passed through the filter chain, and then what emerges on the right-hand side is what gets sent out to the server. So the response comes back from the server then, and that is passed through the filter chain, and what emerges on the left-hand side is the HTTP response that gets sent up to the application. So all of this is transparent to applications. The application behavior is exactly the same, whether or not filters are installed or not. So we'll take a quick look at the filter interface itself. There are 4 methods on the filter interface, and each will have a default implementation. So applications or our filter implementers only need to implement the specific methods that they're interested in. Before a request, that's called once for every request, and it's given a HTTP request and a modifiable HTTP headers object if the implementation needs to modify any headers. Second method then is on request body part. So this will be called always at least once and possibly multiple times depending on the amount of data that's being sent. So this is quite a powerful and flexible API. The method it's passed an array of byte buffers and a Boolean flag indicating whether this is the final call for this request or not. So the implementation can then it can look at the data in the buffers, possibly modify them, possibly replace them completely, or buffer them, store them internally until a later call. But it must return. So it returns an array of byte buffers also, and what's returned from one filter is basically passed as the input to the on request body part method for the next filter in the chain. So then we have the after response method. This is called once for every valid response, and this returns. This is allowed to do a number of things. For instance, it's allowed to examine the response headers or response codes, and it can decide whether to allow the response to continue or whether to cause an error. Or it also has the possibility to cause a new request to be issued and sent out, completely transparent to the application again, and in such a way that the response to the second request would be the one that the application eventually receives. We have an example of that later on. And then finally, the on-response body part method is the exact equivalent to the on-request body part method. It works in exactly the same way. So to take a simple example of a filter, this is a real simple logging filter, which you can see here the before request method logs the request method and the request URI. The after response method simply logs the response code and nothing else. And then the on response body part method. So this examines the returned response body. And all it does in this example is that it counts. It keeps a byte count. So across each call of this method, a byte count is maintained and incremented or updated with the size of each byte buffer that's been passed in. And then in the final call, when complete is true, it logs the total count at that point. So it's quite a simple example. We have a slightly more complicated example here where some simple modification of the body might occur. So you can see here this, I'm calling this an encryption filter, but it could be any kind of content transformation filter. So this filter object maintains some kind of encryption state. Its onRequestBodyPart method then allocates an array of byte buffers, and then it calls some kind of external encrypt method, which is where it's given the input buffers, and that method generates a new byte buffer which is put into the out buffers array, and then it's that array of out buffers that's returned from the onRequestBodyPart. And then the onResponseBodyPart is exactly the same, except that it's calling a decrypt method instead of encrypt. So that example just shows very basic modification of data in a kind of a streaming sort of a way. This example here shows a slightly more complicated example. And what we're trying to do here is, this is trying to illustrate a case where, probably an unusual case, but let's say the filter needs to read the entire request or response body, and based on the content that it sees, it prepends that content with some kind of a header. So that sounds like something that's quite difficult to do in a filter, but the way you would do it here is that you allocate a linked list or some kind of storage structure for the byte buffers, and in every call of onRequestBodyPart, we simply add the incoming byte buffers into the stored linked list, and we do whatever calculation or that is needed to generate the header that we're looking for. And in all cases where the complete flag is false, then we return null. So what that means is that the filter is not returning any data, is not passing any data on to the following filters in the chain until the very end. So when this is called the last time, when complete is true, it generates this special buffer which contains the header that we're interested in. It prepends it to the beginning of the list and then returns the entire list onto the remaining filters. So it's kind of an extreme example, but it just gives you an idea of the flexibility and power that powerful things that can be done. And finally, the final example for filters is, I'll just go through this very quickly. This is a kind of a partial implementation of a redirection filter. So it's only interested in the response. So it implements the after response method. It checks for a response code indicating redirect. It creates a new request based on the current request, but sets the request URI to the contents of the location header, which is a standard thing to do for redirect. And then it calls this special new request method on result, which is telling the system to send out a new request and wait for that response to come back before sending the response up to the application. Okay, so that's everything on filters. I just want to mention briefly a couple of other classes or interfaces in the API that perhaps most applications won't need to use, but HTTP connection cache is one which allows a certain amount of configurability of TCP connection pools and keep alive behavior. And if you can see at the bottom of that slide there, we have a concrete implementation of that class, so that's probably going to suffice for most purposes. But if you need something more specialized, then you would need to implement this interface. So what's highlighted there at the moment is a sub-interface which provides the view that cache implementations will have of connections, and so this shows you the information that the cache has of connections and what it can use to define its strategy for caching. And then the cache itself then just implements these two methods, return to cache and get connection. And the client implementation calls these two methods to put connections into the cache and then to retrieve connections from the cache. Okay. And then the final class I wanted to mention is the HTTP upgrade handler. this is it's basically an implementation of the upgrade, the generic sort of upgrade mechanism in HTTP, and it will be used for protocols that use that mechanism, like WebSockets. So it's kind of similar to the filter API in that the upgrade handler, HTTP upgrade handler, has methods like modify request and examine response. So that allows the handler to add in special headers that may be specific to their protocol, and it also allows them to examine responses to make sure that the expected headers in the response have come back. And then finally, set connection is called. This is where the client hands over the TCP connection to the protocol implementation, such as WebSockets, and then you have the upgrade connection interface itself, and that shows what the protocol implementation, such as WebSockets, can do. So it can call get channel to get an asynchronous byte channel, or it can call get input stream or get output stream to provide a blocking raw channel for reading and writing bytes. So this is the final slide, or the final topic, only 2 slides. Just a brief word on security permissions in this API. The permission checks will be similar to the existing client in terms of the checks would be done in the same place for the same kinds of things, but we will be using a new permission class instead of socket permission. It may be called HTTP permission or URL permission or something like that, but it's a higher level permission class than socket permission, which will be more suited to HTTP usage. So for things like proxy access, socket permission is still needed for that. And then there will be a number of new net permissions then for specific things like setting and getting caches or filters or upgrade handlers. So to show an example of what the in a policy file might look like with one of these new HTTP permissions. So you can see here a grant of a HTTP permission to some URL foo.www.foo.com/path, and then it lists the methods that are allowed. So what this permission is granting is that whoever has this permission is allowed to do gets and posts to any URL below this path. So it's a kind of a higher level way of specifying permissions than the way socket permission worked previously. So finally, just to repeat what Danny said earlier, the source and the API, it's all freely available. Even prior to being, it hasn't been integrated into JDK 8 yet, but we've been using a java.net project initially for managing this. But you can download the stuff from there if you want to look at it. The API has nearly complete Java doc, and you can use it and try it out. We also discussed the API. It's not 100% complete yet, so discussions take place on the NetDev alias there. Number of open issues. We still have to define an authentication class for at least that, and provide an implementation at least of basic and digest authentication. And we also have to complete the security permission work. I think that's it. If there's any questions, we can take them now. Yeah?
One of the things I did notice in your code example was posting of the resources. Our HTTP connections, let's say if something goes wrong and my code doesn't close it, would that create a problem?
Yeah, so the question was, what about closing of resources, that there wasn't any examples shown. Yeah, we do have a close method on, I don't know whether I think it's on HttpResponse, but there is a close method there which will close off all resources.
Auto closable as well.
And which ones?
Auto closable
response.
Response.
Yeah, I think response is also implementing auto closable, so that whole mechanism works as well.
Question.
WebSockets are going to support them out of the box, so I'll have to implement all those operating interfaces.
Do you want to?
Not out of the box, not in the JDK, but we. As part of the WebSocket project, we'll probably provide an upgrade handler and implementation of that interface as part of that, in part of the client. side of the WebSocket project. Yeah.
What happens if you try to talk to a host that doesn't exist when you get a DNS error? Where does the error catch up?
Yeah, so what happens if you try to connect to a host that doesn't have a DNS record? Yeah, well, connection errors, any kind of error. We didn't show the exception mechanism all that well, but I mean, if you're using blocking mode, it's clear enough some kind of exception will just be thrown from the blocking method itself. But the on-error method, if you remember that, and if you're using asynchronous mode, that has a throwable parameter which will contain whatever exception caused the thing to.
Okay, so if it was a DNS unknown host exception from the low-level socket layer, I would get that. I can get it if I want.
Exactly. Yes. And the same through the future mechanism as well. There's also a way of getting execution exceptions from that also.
One question.
Is there going to be a default implementation as part of the Java JDK 8?
Yeah, that's the plan. That's the plan, is to include it in JDK 8.
Question.
Did you make any changes to the SSL infrastructure, like if I were to connect to a host with unsecure certificate, right? People browser or some stuff like that. Any changes around there?
So the question is to do with SSL. I mean, okay, in general, to do with SSL, we implement SSL using the SSL engine class. So we defer everything to do with SSL to the whole javax.net.ssl package, and I hope we've provided enough hooks to configure everything that needs to be configured. And but we don't do any SSL specific stuff in our own code.
I could override some methods and get over unsecure certificates and stuff like that.
Yeah, I'm actually not really qualified to answer kind of SSL specific questions.
About SPUI, is there out-of-the-box pluggable?
Yeah, that's an interesting question. SPDY. Yeah, there's two things there. We have to, we want to be sure that the API will fit the speedy model.
Well, it's HTTP model. I mean,
yeah,
because it's basically quite your HTTP.
So then, assuming that that's the case, then it's just a case of somebody implementing, providing an implementation. And we didn't really go into the service provider part of this API, but it's a fairly simple mechanism to load. You can have multiple providers even running at the same time for connected to different clients. So it should be possible to do things with that. Yeah. I think we've run out of time actually, so we're probably available if you have any more questions outside. Thank you.